For today's application, I'm excited to bring you a marine products example. So let's go ahead and jump right in. So today we're going to take this marine product. This is a mooring device to put on your dock to then insert poles into that then allow you to moor your boat to the edge of a dock there without bouncing up against the edge. This will hold it up off the side of the dock. So this part is one that I had worked on and I had scanned and reverse engineered. And today we're going to focus on the modeling of it as usual as we roll back. But we also are going to take a timeout in the rollback feature. And what we're going to do is talk about the scan merging and alignment. And I'll focus a lot on the alignment of this object to the world. And then we'll talk about it aligning scans to the world CAD coordinate system a little bit more in depth, and then roll back through the history as well and show how this was modeled, just to keep the same pattern that we do with our webinar. But what I wanted to do really is take applications like we have here and then utilize that model to teach something important about the software as well as show the entire application. So let's go ahead and jump over to the next slide here. With this one, I believe we scanned it with a device like this right here, a white or blue light structured light scanner. You can call it whatever one of those things that you want. So it was one like this one. We also have this one right here, which we could have scanned it with as well. And then you see down here, this is in the structured light. This is in the structured light category as well. And I believe that's all for this slide. All right here too. This one right here and this one. So I'm not missing one. These are all different structured light devices that are out in the market that you can use to scan an object like this. Honestly, it was a structured light, but you could have scanned this with a handheld as well. So this right here would have worked. It all depends on what you have available at the time that will work for you. So scanning with a handheld or even these arms would work just fine. The only ones that probably wouldn't work as well, right, are these long-range scanners. These are that are in the millimeter accurate range are probably not going to work for an object this small. So the reason why I point out this is that we have this with a white light is I'm going to go through like just the process of merging scans inside of Design X and aligning it as well as aligning it to the coordinate system. So registering the scans together and then aligning it to the world coordinate system are things that we will cover with this webinar. So with that, we'll go ahead and jump right in. As usual, we start out with this first slide that's just talking a little bit about Design X and what this product does. And I just try to give the summary in slightly different ways for people that have heard this over and over again. I'm sorry, but I just want to make sure that everybody understands what this product is and what its intended use is. So as I always propose this, there over the many years, 30 plus years, devices similar to one screenshotted here on the left-hand side came about on the market, capturing 3D measurement data. And many of them capture high resolution and in some cases high accuracy data, 3D point cloud information or polygon information that is very high density. And when those devices came about in the market, immediately engineers and designers and people within quality departments saw the possibilities there that these devices could be used to capture the shapes of parts and bring them into 3D softwares to either make comparisons and measurements or reverse engineer the shapes of parts. There became quickly people noticed that that data was too dense and of a different nature than most of the 3D CAD softwares that existed in the market. So specialized softwares cropped up to deal with that. And Design X is our solution where we take these high resolution, very high density scan data sets, and we allow you to work with them in a native environment and recreate CAD models or other deliverables from that data for use primarily in manufacturing, but not only limited to manufacturing, and lots of other markets, as you see on the right-hand side, whether it's CAD, CNC softwares, and just going straight to manufacturing. And as you can see, the additive market where printing and those types of deliverables are also captured. So Design X, its specialty is taking that scan data not as a second class citizen into the CAD world, being able to extract whatever it is that you need out of that information to then send downstream in your manufacturing workflow. And our webinar weekly focuses on different applications similar to this one that's shown right here, where these impellers are reverse engineered to recreate these highly organic shapes into CAD models, is highlighting different applications similar to these that are success stories for Design X. And along the way, I give tech information or tech tips for current users of the software. So this has multiple layers to it where we talk about successful applications where we've utilized the software, and we try to sharpen everybody's skills by highlighting specific applications that are very interesting. So let's go ahead and switch over to DX and get started. So as you can see, I have some modern art here on the screen, also known as some 3D scans that were captured from different viewpoints. And what I have here is kind of like a worst case scenario. And this is basically saying I 3D scanned an object, flipped it over, 3D scanned it, and I just did that, and it dumped into the software. Lots of softwares actually will use targets and automatically piece them together. There's lots of different ways that the data gets collected in different with different scanners. So what I have here is kind of like a worst case scenario. That way I'm walking through something that will teach a lot of different things all at once. So as you can see, today's format is going to be slightly tweaked from the normal format. What I'm going to do is we're going to use the scans from this scan and take that information and piece it together and talk about the process of putting the scans together and aligning them or registering them together. Then we will also transition into another section that we will then align the scan to the world and talk about different methods of doing that. Then I'll bring up the model, the completed model, and do the rollback of what we normally do on this session. So that's going to be the format today of the presentation portion. So we'll go ahead and jump over here on the left-hand side. As you can see, if I drop down, hit the positive checkbox there on the meshes, you'll see I got a bunch of meshes, and look at, they're not organized. Sometimes when you scan, you can actually scan directly into DX and create groups. So what I'm going to do right now is look at the naming convention you see here, and this is named 1 to 16, and then it starts at 1 again. So what we're going to do is we're going to say 1 to 16, highlight all of those, and create a group. So we're going to manually, and then I'll turn that off, and we'll do the same. Now while I'm doing this, I'll point out that sometimes when you scan, the names, depending on what scanner you're using, the names will tell you like group 1, scan 1. So there are often times that it'll say like group 1, scan 1, and you can select them that way. This is kind of a worst case scenario, but at least there is logic here where the scans came in to the software in order, so I'm able to take every 16 scans and select them and group them together. So now when I do that, we'll just sit here and we will, so you'll see that that is group 7, group 6. So they're all organized properly. If you were ever wrong on this, you can just highlight all the scans that you believe belong to one group and then select them and drag them to a group, or even move these around where you can come into this group and you can say, I want to move this to another group or remove it from that group itself, right? So as I look through here, you'll notice another aspect of the modern art is you'll notice that the scans are very well aligned here. And when you see a lot of bisecting data like this, that's telling you that the data is very accurate to one another. But if you see a lot of individual colors, which here, let's find an example of this. Not the best example. What about this one? Here's another one. When you see a lot of individual colors prevalent, that means the scans are probably not aligned to each other very well. So what I tend to do is just take the individual groups, come over to Global Fine, select that group, hit apply, and you'll see here, if I just give it a second to run, it will then look like the other one because the data is going to be overlapping so well and it's so tightly integrated. The checkering of the colors intersecting each other will demonstrate to us that we have a very accurate alignment visually. So you see here now that it finished, this is exactly what I'm talking about. Now, you have to account for sometimes individual shots see data that other shots did not. So if you see lots of bisection of color and then one little area that's only one color, that's because that scan is the only one that saw that region. So do not take that for scans being inaccurate, right? So what I will tend to do is just cycle through and you look for, here's another example of this, and then come over and just say, I want to do a global, and then run that. So you see the same thing happen there. And you could get away without probably doing this because you'll notice that when I go ahead and do a alignment between all of these scans, we're going to run that again. There's a cautious way to go about working with scans. And then the other thing I'm going to do before we move along is crop this one scan. It got the table in it. So if I just rotate around, I'm just going to use that rectangle. I'm going to turn on select through. And I'm going to select the table, hold shift, and that little piece right there, and then hit delete. Now that delete is done, you can come in, and if this stuff bothers you, you can toggle over to maybe this tool and hit delete there. Then these little areas here, you don't have to fix this. I'm just doing it just to show this is a way that I would do it. We'll just zoom out here and do this one as well. But a lot of times I will just show, like, I'll go above and beyond here of doing things just to demonstrate what's possible inside of the software rather than just letting it go. Because there are instances where letting it go could help. It's not really a big deal. I don't have to fix it. So there. Now we'll go ahead and if I click and drag on the eyeball and drag down, you'll see that it turns on. That's a little trick there, a little shortcut that we have by clicking and dragging. So now I have the modern art again. I got everything on screen. We can come over to alignment and say align between scan data, align based on pick point, and I can just say 1 to 2. We're going to align 1 to 2. And what you do is you orient them on screen in a similar fashion. And I can then zoom in and click common points between the two. So click a common point there, zoom out, zoom back in to maybe like this E. There. And then maybe somewhere over here. There. Now, if I wanted to, I can do this, where I could just turn them on as I go, because I can get a visual on whether or not these are aligned to each other, and they are aligned pretty well. And again, we're just trying to get them close to each other in this instance. And then once they are close, we're going to do a global find, this one down here, on all of them together. So now that that one is carried over, another thing I can do is I can click on all of these. And if I want the colors to go away and just make everything one color, I could just make all the scans one color and continue on. So now I'm going to say under reference, click those first two groups. And then under moving, I'm going to select group 3 and I'm going to turn it on. And it helps to select points that are spread out and not directly in line. So if I do something along these lines here, so if I grab these two, I want to select something like over here. And you'll notice I'm not doing them like perfect, like zooming way in. You can, but I'm just getting close because we're then doing a very basic global find in the background between the two groups of scans. So you just need the points close together. There are instances where if you don't get it close enough, then it does not work, right? That is possible. So depending on your experience, you can tweak the way you select those points. If you're measuring parts where you're pushing the limits of what's alignment, what's possible with this alignment, then you might want to zoom in a little more than I am. So we'll just hit that as well. All right. Now we'll just add another and just keep rinse and repeat here. And this has 7 groups. There are reasons why they may have had 7 groups when they scanned it. Sometimes you don't need that many, but this is just walking through an extreme example of piecing together 7 groups. And then some scanners have targets which will automatically recognize and piece them together. So again, this is an extreme example again of what it would take to piece something together and what workflow I would go through. And even with this It's really not that difficult just to cycle through these and piece it together. It really doesn't take that long. You see here, what we'll do is we will use these points here, like right there, and right here. And here is an example of how people commonly mess up, exactly like I did. I just messed up. When I clicked that point, it didn't accept it. So I'm going to hit undo, undo, undo. So this point, and then click that point. Now they're matched up again. That what I did is a very common way to mess up, where you're clicking back and forth, and sometimes you get them out of sync for a number of reasons. One of them is I didn't click on the scan. I was just a little bit off into the gray space, and it didn't capture the point, and I didn't notice. And then that happens where it didn't grab it and piece it together. So undo is the way you're going to back out of that, hitting Control Z. So now I'll just piece on that last one, align it, and we are good to go with the merge. All right, so we'll just click. So you can do 1, 2, 3. Just make sure you get them in the right order. And then you'll notice they're a little ways off there. I went ahead and did it that way anyway, just to see how well it fits it together. So you see it did get it pretty well, but you'll see it has a little bit of a mismatch there. So let's go ahead and jump over to Global Fine, select everything as moving, and let it run. So it went ahead and finished. And look at that. It just grabbed all of those and snapped them together. And we'll go ahead and hit accept. And just as a example here, just to let you guys see how much data this is, I mean, it's not a crazy example, but it is an example of like, it's way too many points. Polyface count, this is 80 million, 40 million vertices for just this part. So we're going to reduce that down now. First thing we'll do is just get rid of the little piece that's bothering me out in space. And just say, hey, let's get rid of that. So now what I tend to do is say, let's go ahead and save. So you would just come up to File, Save As, and save the file. And then move on to the next step. So now that we have this aligned, we'll go ahead and jump over to Polygons, Merge, and I suggest using Volume Merge. So while that's calculating, I will break down some of the basics. So we got all those scans. I basically just clicked on all the meshes, throw it in here. Click on Volume Merge, bump it up 2 clicks is what I would do, and then turn off Remove Original Data, and then hit OK. When it calculates, Surface Merge is a lot, it's primarily for, it's an older algorithm for more 2D data. It's an older algorithm. Volume Merge is a very fast algorithm that if I crank it up like you see here, it then increases the accuracy, so you get the best of a fast algorithm that is tighter accuracy. Technically, the mesh construction algorithm is a little bit more accurate, but takes longer, and I don't seem to see the same benefits of using it over using volume by bumping up the accuracy, right? So I tend to not see as the same result that I like out of that one, but it's technically a more accurate. And then the HD mesh is more for long range data. So if you have a terrestrial long range scanner where you're scanning like an entire building, one method is to use the HD mesh construction that works really well for that data. So my go-to is this volume merge is where I land. That just simplifies it for a lot of people. This covers the majority of what you would want to merge. If you need to, you can branch out to mesh construction or HD for other reasons there. But that's just my 2 cents on the algorithms. So once it finishes merging, you see that I have one scan, and then I still have all my groups because I said to keep them. And usually what I do is I go ahead and I hit File, save the file, revise it up, do a save as again, and then get rid of all of the scans themselves, and then save it again with just the merged version. So one thing that I can do is I can say ungroup, new group, delete all at once. So after I delete all those, then I'm down to just the scan. Now, we can talk about editing, some scan editing now. So just coming around and looking at the surface of the part, and you see certain things like this. There's different ways of going about. I can click on the main object itself, inverse, do that one more time, inverse, and delete any other little bits that are floating out in space as well. Rather than clicking on that piece and deleting it, click on the main object, inverse. As long as I'm sure that anything that's not disconnected, I want to go ahead and get rid of. But yes, that's a way that you can do that, where you can get rid of all those little pieces. And some of these things, it just depends if you want to fix it. We don't have to fix it for the reverse engineering that we're doing. But I figured I would talk about some of these repair tools while we're in here again, just to reinforce some of the things that we've talked about. So I can come into the hole filling tool, click on the boundary, and I have it set for tangent fill right now, which works well for these edges. And if I would just want to fix one and then hit enter and fix just that one, I can. And you see it does a pretty good job of repairing that. Now I can also just double check and see this object here is still 27 million triangles. So let's go ahead and reduce it down. I don't need 27 million for what we're doing here. So let's go ahead and use the decimate tool and reduce it down to like 2. So 2 million, and I always have this curvature cranked, maybe all the way. Let's crank it to 11 this time here, and then hit enter and accept that and let it run and remove a lot of redundant triangles. So now that that's finished, it will work a little faster than it did before. So I did a one-off hole fill, and you'll see that that error is popping up, basically just telling me before you go fill stuff, you can run the healing wizard. So I'm just going to run the healing wizard, and it will go ahead and repair a lot of this stuff automatically for me. So I'll run that. Actually, I could run that before my decimate, after my decimate. You can run this. I actually intermittently run Healing Wizard throughout the process. And then after I do hole filling, I usually as well like run it. But I could do this where I select boundaries, a bunch of boundaries that I want to repair all at once. So you see I can just tell it, go ahead and fill all of these here at one time. You see I'm being really aggressive here. I'm not going to do that one, of course, but we'll go ahead and let it run on those and then fill all those. You see, it did a pretty good job. Now, inside of this hole, you could come over and do some bridging and stuff. It's a good example of showing that you can do bridging. So if I wanted to bridge all the way across here to there, bridge across those, and then I could do a fill partial here. And I accidentally did the wrong side, so I could say undo. Let's do that one more time. Change it to partial. There. And then on this side, that's all now bounded. So click on boundaries again and do that entire bounded area and just accept everything that I did there. So that's a little bit of how to do that. And you see, I could take a gander at this. Here's one way of doing this one. I can select edges and shrink it back. You see this? If I want to. And then come in and do a hole fill. There's just lots of different ways of thinking about it. Like I could manually, I think a lot of people would just manually edit that. But I'm just trying to think of other ways you could go about doing it. And then Smart Brush, I can come in with the Smart Brush, hold Alt to change the size of the Smart Brush, and just come around and smooth out the transition there. In Smart Brush, sometimes, let's see, enhance, deform. I could decimate that too, like locally decimate that. This one's got some twisty triangles in it, so I'm just messing with it. But you know what I could do is just go ahead and accept that. I could just delete it, just do something along those lines. So there you go. Trying to think of anything else to show in here, but defeature. I could do a defeature and toggle over. I could window in and say, hey, that I want to get rid of. So you see how defeature will allow me to take these defects in the surface. So I could take that area. We'll just run defeature again. Select that area and get rid of it. You see that? If I want to fill this inside area too, I could go ahead and tell it to do curvature based fill. Does a pretty good job there. So there, let's do this one here too. Select that. Let's see what defeature does with that. Not too bad. So now I'll just go ahead and fill a couple of those little holes. You can also go into hole fill and say fill all, and then deselect ones that I do not want to fill. So if I visually see things that I don't want to fill, like these, like that. In this instance, I think that this will work pretty well. Just visually deselect things that I know I really don't want to fill. Tell it to fill all the rest. Does a lightning fast job there. Then come on over to my healing wizard. And it didn't find anything, amazingly enough. So I can get out of it. Save your file. And we will get on to the alignment portion. So now that we're going to align this to the world coordinate system, let me just turn on the planes. You'll see here, if I hit front view, this piece is just floating off in space. So I need to align this to the world coordinate system. And there are, I kind of categorize 3 different techniques of how to construct the geometry. And then from there are lots of different alignment methods from there. And sometimes I employ multiple techniques here. You'll see what I mean in a second. But just to get started, I will show, again, 3 different types. Let's start off with regions. So I can come over to the region tool, hit auto segment on this entire part. I run it with sensitivity 20 and smooth. And you'll see here, just use the settings that I use here. So I'm going to go ahead and run the region group. And then we will use these region groups to align. This is just the first method, and I'm showing it first for a reason. Just because I'm going to use regions in another method, but it's a little more complicated than that. So we'll just let it calculate these, and then we will align it. So now I have my regions. I just double check some of the ones, especially the ones that I want to use. So you see here, I'm clicking on it. I want to make sure that it's defined as a cylinder. And if it's not, I can click on it and go over to properties and make sure that it's a cylinder. And then down on the bottom here, plane, make sure that's a plane. And so on and so forth. So one way to align this is by using these regions. If I come over to home, I come over to interactive alignment. We're going to be using the interactive alignment tool the whole time. This is how you interactively align the scan to the world. So I'm going to select that scan, hit next. And this is technically supposed to be like the before and after over here. So I don't really care about the before and after. So I actually just drag this over because this coordinate system will move to where I put it when I start selecting stuff over here. So to start off with, we have 3, 2, 1 and XYZ. And XYZ is much more robust. 3, 2, 1 will allow you to do plane, line, point, right? And allow you to select a plane, then features that form a line, and then features that form a point. And when you do that, it'll align. It's more of a limited alignment, right? So I tend to use XYZ primarily all the time, but we can talk about 3, 2, 1 here in a second. So the first thing you're going to do with XYZ is it divides up the translation and the rotation into 2 categories. Position is the translation, and the rotation are broken out into these 3 things. So for XYZ, you want to have something that breaks down into a point to set your position off of. But you don't have to create any constructions, like I didn't create any yet when I created these regions. But what I can do is I can select that cylinder and that bottom plane, and it will put, you'll see the origin at the intersection of the plane and the cylinder. And then now I can come over to my rotations and say I want to set Y, and I can reuse these too. I want to set Y to that region, and then I can flip-flop it and say I want to be Y up. And then I could say I want X to be this cylinder, and it will square up that with that cylinder, even though that's off at an angle. And then I can flip-flop that too, and then hit OK. So now, if I hit front view, you'll see that it's angled there. The 0 is down there. And I have a beautiful alignment. So that is using regions with the interactive alignment tool. So that's one method to do it. So I'm going to hit undo. And we're going to come back. And instead of using that cylinder axis for my second, and instead of using regions by themselves, I'm going to create features. So I could select that region and I can say, create a vector. And we're going to create a vector from a cylinder axis. Go figure. And I there created a cylinder axis. Now I can create a plane. A lot of people end up doing it this way because they don't know that you can do it based on just regions. And then you'll see now I can take vectors and planes and create a point. So there, we got all this is very similar to what we just did, except for the shortcut way to start off with. But now other thing that I can do is I can look down this part, and this is a very symmetrical part. So I can come over and I can say, I want to draw a line down the center here and create a plane and hit OK. So once I have that plane and the mesh, I can come back over and say, I want to create a mirror plane from the entire part. And I'll hide some reference entities here in a second because I'm moving pretty quick. I'll hide my XYZ. So now you'll see that I calculated, and I'll hide the other one too, a symmetry plane, a mirror plane down the middle. So it calculated that based on the entire part. So instead of clocking it based on my axis of a cylinder only, I am actually going to clock it entirely based on this symmetry plane, which will then inherently distribute a lot of the error across that plane into my alignment. So this method is using features. So I'm going to now, for my position, I already created a point, so I'm going to say create point is my feature there. And then for my Y, I'm going to use that plane. And then we'll just flip-flop that too. And then for my X, instead of using this axis like I did before, I'm going to say, let's use the symmetry plane. And then I can flip-flop that if I want to make it the same as before. Now if I hit OK, actually it might not be the same as before. I flipped it the other way, I think. We'll see. Yeah, we made it different. But that works. So I aligned it based on, and you'll see that the symmetry plane doesn't come with it, but the symmetry plane matched up with the right plane anyway. So now you see if I turn on my planes, it aligns with the origin there. So that is how you would align using features. So you see that I aligned using regions, I aligned using features. I can actually use both of those at the same time. So if I wanted to just only create a symmetry plane and then do the rest with features, regions, I can do that. And then the final method, we'll just hit undo and go back to the beginning. The third method is, instead of using those constructions, I could also use sketches. So this way, for this specific part, it's not the best way to do it, but this is really helpful for people that are presenting the software all the time. If you're presenting the software all the time, sometimes you're put on the spot, like you need to align the thing fast. And when you align the thing very fast, sometimes you're not thinking about the best way to align the part, and you can make mistakes. So with lining with sketches, I can come in and I can just draw a circle here and set that as my origin. And then I could draw a circle. Oops, we'll just deselect that. I'll accept that one, and then we'll draw another circle here. And then I could come in and draw a line from circle to circle. And then a 90 degrees from that. And then I like to extend it out to the circle like that. So that way they're separate entities like this. There we go. Turn on my mesh, and now I can come over and say interactive alignment, and instead of using regions, instead of using features, I can use sketches. So if I just turn that off and say I want that to be my 0, and again, for this part, this isn't the way that makes the most sense to do it. I'm just showing this method because it is it's a very good method for other parts. And then Z here, if I want Z to be there. There we go. And then I can flip-flop and turn on the mesh. And the cool thing about this method is I could sketch where I want my coordinate system anywhere. So I could just draw, 13 inches away from the center is an axis. And you see the sketch does not move with it. So I'll just turn the sketch off. But you'll see that we aligned it based on the sketch to the world coordinate system. So those are the 3 types of alignments that you'll see. I say methods of input geometry. So I can use regions, I can use features, and I can use sketches or model information. I don't have to use just sketches. I could model the origin where I want it, but it's a little unnecessary. It's a little excessive there. But it helps to kind of understand that is your method for aligning. So we can talk about more alignment stuff in the future. Different types of alignments that I can do, but I wanted to do this overview of alignment for this part as it pertains to this one while we're at it. So now let's go ahead and jump over to rolling back the model on this one real quick before we run out of time today. So let's go ahead and roll back on this guy. We'll roll all the way back. There you go. And roll forward. So we are going to extrude the base. And looks like we're going to cut the surface. So we went ahead and extrude that surface there and did it as a surface and cut it. And then the little base plates where you mount it that are actually level, because this has draft on it. And then Boolean cut those away. And we'll turn the surface off. And Boolean cut that away. One interesting thing about this one is I believe we filleted the body before. Filleted the body before we cut it away. Roll forward there. So we modeled this guy. And what we did here is we went ahead and did a 3D polyline curve there. There's a bunch of different ways you could go about doing this. You could just sketch and draw or extract the sweep here, and then they did move faces on each side there. Roll forward, and with this one, this is really interesting how this was done, is go ahead and do a loft at surface. So we'll just show the sketch there, like so. Then mirror it, sew it, fill face on the ends. Do a move face on each side and fill it. So just turn that on there. And then on the base here, did that as an extrude with fillets to make it more idealized than it was there. It may not be exactly the way it is, but that's more idealized. And okay, we went ahead and those are tapered. So revolved that, fit those. So we transformed and moved it down there and mirrored it across. And then apply fillets, booleans. So we went ahead and cut the middle away there. After boolean this to this, cut the middle away. We did a cut away from here. So let's see here. Extruded with draft, a surface body. Then did a fill face to the top and bottom. Actually, this is interesting, so I'll roll back. So extrude loft down, fill face, trim. There you go, created a solid out of it. So we'll turn the solids on. Oh, no, we just kept it as a surface and then did a surface cut. Never mind. Made a liar out of me. And then let's see where we go with this here. Oh, there's another little cutout there. So trim these together. Trim that. Oh, we used the solidify command, which is awesome. So they created a solid based on surfaces that enclose a shape, and then boolean that away there from that. And then the rest are just fillets, filleting the entire thing to death there. So now, and then you fillet the whole thing. So there we have the final modeling process.